Welcome to the HGAPS speaker series. I'm Eric Youngstrom. I'm a professor of psychology and neuroscience at the University of North Carolina and the co-founder and executive director of Helping Give Away Psychological Science. HGAPS is a 501c3 nonprofit organization dedicated to bringing the best information about psychology and science directly to the people who would benefit. This talk was made possible by Colin Park and Kira Clemes getting a grant from the University of North Carolina Student Government Association, which paid for us to bring our speaker for one day and one day only to the University of North Carolina at Chapel Hill. So seated next to me is Dr. Tom Frazier, who I have known since 1998. I am a huge fan of his work. He is one of my personally most admired and respected colleagues. And he has become a really good friend, which is great when you're having a moment like this, like bulbs out, we need to change rooms again. So super grateful to have him here, super grateful to be able to share that with you. So without further ado.
Thanks, Eric. And thanks everybody who's online today. Appreciate you joining us at 4 o'clock in the afternoon. My goal here is to talk to you a little bit about a program of research that I've undertaken over the last 5-6 years. And like I said, I've been working on this stuff for about 5 or 6 years, and it's sort of starting to culminate over the last year or so in a set of measures that we think can be useful for people with autism and developmental disabilities. And so I'm just going to give you an overview of that. I'm going to go really, really quickly. And the reason for going quickly is, number one, I want to keep you awake. And number two, I'm not going to bore you with some of the details. I just want to give you a flavor for what we've been trying to do and how we've been trying to do it.
No, we don't want to give subtitles a try.
There we go. So before I go any further, I do have disclosures. I have a lot of them. The ones that are most relevant to this particular talk are on this page, which is the funding that I received for these to develop these measures, including funding from several different genetic syndrome foundations that you see on the screen here, as well as Autism Speaks and the Simons Foundation. So why do we need good measures? Well, that should be fairly obvious, especially to this audience, but in order to understand the natural history of autism and other neurodevelopmental disorders and neurogenetic syndromes, we've got to have good measures of different neurobehavioral functions so that we can understand the profiles of strengths and weaknesses. And if we're going to search for genetic modifiers, neurobiological modifiers, and modifiers of course and outcome, then we need good measures of those particular domains. And then for clinical trials, we need measures that are going to be brief, repeatable, and sensitive to change. And really, a lot of this work was motivated by my experience as the lead neuropsychologist in the RDCRN, which is the Rare Disease Clinical Research Network, where we were studying 3 different genetic syndromes, P10, tuberous sclerosis, and Phelan-McDermid syndrome, or SHANK3. And what I learned in that process was, yes, we could put together a battery of measures, but the battery was really, really long and incredibly burdensome on the parent, who was the typical informant, usually a mom, and the cost was not insignificant either. And so we could do much better. And our existing tools, unfortunately, are not really specifically designed for autism and many of the neurodevelopmental genetic syndromes that are associated with autism. So we wanted to undergo a process whereby we would engage clinician scientists, experts, the caregivers themselves, and the patients as well in the development process of the tools. And we know that even on these existing tools, which in many cases are well validated, unfortunately, not all the items are useful, especially for cognitively impaired or non-speaking or minimally speaking patients. And so we need measures that are going to have where all the items are going to be applicable. if we want to collect data repeatedly, then we're going to need to do this online. So this is hard for people to believe, but I actually had this idea before COVID because we were wanting to study not only autism, but these neurogenetic syndromes. And these people are scattered all over the country, all over the world. And in order to capture data from them, you have to have online measures. And then if we could have multiple domains that are co-normed, then that really facilitates profiling of strengths and weaknesses, not just at the group level, but at the individual level. So our project here was to develop and validate an online multiple domain neurobehavioral evaluation tool, or NET for short. And the NET that we wanted to create had both parent survey scales, so your typical informant report, parent report scales, but also the patient performance measures that we would collect via the webcam. And again, we wanted these to be reliable, we wanted them to be valid, we wanted them to be sensitive to change. And we wanted the key domains here to be selected such that they were really the most relevant domains for patient functioning and well-being. We wanted it so that the measures would be easier to collect than the existing measures. We knew we weren't going to be able to do another battery that was going to take parents 2.5 hours to fill out, or that was going to require 2 to 3 hours of direct testing with the patient. So we wanted stuff that was going to be really brief. And of course, we wanted stuff with good psychometric properties here, in this case, clear factor structure, reliable, sensitive to change, et cetera. So this is a complicated slide, but I can simplify it, which is just that we had access to various different groups, including an idiopathic autism spectrum disorder group, and also these 6 other genetic syndrome groups. We've actually expanded that now. We have several other genetic syndrome groups involved. And then we had a healthy, I shouldn't say healthy, neurotypical sibling controls and unrelated controls as well. So these were the groups that we were going to study and use to develop the measures. And then the measure development process was really an iterative process where we went to the patients and the informants and the parents and said, hey, what measures, what domain should we capture? What content do we need to gather? And then once we've written these, are our scales going to have good content coverage? Are they going to be applicable to all patients? Are they going to be relevant to the groups that we're interested in studying? And obviously, are they readable? Are they fairly easy to complete? On the webcam measure side, we were looking at things like, are they easy to use and administer? How many patients can we get valid assessments from? And what's the overall completion time? And our goal was really to set the overall completion time for those to be less than 15 minutes. And so ultimately, this led to a final tool, and I'll talk about that process more in the next few slides. But once we had the final tool, we wanted to administer the tool at baseline, 1 month, and then 4-month follow-up. And so we're in the middle of that process right now, and I'm just going to give you some of the preliminary findings. So we looked at 7 groups plus our sibling and unrelated healthy controls, or neurotypical controls. Our primary age range was ages 3 to 24, but we were allowing extension up to 45. And we ended up extending, at least for some of the groups, up to 45. We wanted folks to be fluent in English just at this beginning stage because we didn't have the capacity to translate the measures yet. And we wanted people to have access to a computer or a tablet with a webcam. Initially, we were worried about that. We've now recruited over 150 patients, and we haven't had a single family that hasn't been able to participate in that way with a reliable internet connection. So we didn't actually have many exclusion criteria at all. So there were no limitations based on cognitive level or language or speech level. We wanted this tool to be as applicable to a wide range of individuals as possible. They did have to have a supporting participant or a parent or a caregiver who could serve as the informant for the survey scales. And then we did require that our patient participants would be able to attend for at least 50 to 60 seconds at a time because we break our videos up into 1-minute segments. Actually, the final exclusion criteria was at least 40 seconds at a time to be able to pay attention. And in terms of our informant report scales, like I said, we did an iterative process where we worked with the clinician scientists experts and the parents and patient stakeholders to identify the most important domains, the most important content areas to cover. And we were focusing on relevance here across cognitive levels, across language. As many people know, there are measures out there that are otherwise fantastic measures, but will have items on them that will obviously require somebody to be speaking. And those are very frustrating for parents to fill out. I can tell you that because I filled them out many, many times for my own son, and they're extremely frustrating. So we wanted to avoid that, that kind of frustration that would occur in filling out those kinds of items. We wanted them to be brief. Not all of the scales are less than 15 items, but or less than 20 items, but most of them we tried to get within that sort of that ballpark. And again, we wanted all of the scales we came up with to be completed in less than 30 minutes by the parents. So this slide just represents an overview of the process that we went through. And the top of the slide shows sort of 4 different data pieces that we gathered to inform our initial model of what we would want to measure. So our initial neurobehavioral model. And we were using prior neurobehavioral data in these patient populations. We were using our own experience with testing these patients and individuals. And we also reviewed a lot of the existing scales. We did a really thorough review of what's out there. And then we used our experience with testing patients through the RDCRN. And once we had an a priori model, then we went through 2 parallel processes. One was we asked the experts and the patients and informants to give us quantitative ratings about which domains and content areas were most important, and then eventually which items were best. And then we also did a concept elicitation process. This was at the request of the FDA, actually. They suggested that we do this, so we did it. We did it with our P10 patient group only, though. This project was originally funded primarily by the P10 Research Foundation. So we had funding to do this with our P10 patients. We were able to get 12 of them, which is what I'm told is a fairly large number for this kind of work in rare disease. And of the 12, 6 of the patients were diagnosed with autism spectrum disorder. And so we went through that concept elicitation process with patients and informants. I'm not an expert in that process, so we hired a company out of Australia to work with us on that process. Once we were done with those 2 things, the concept elicitation and the quantitative ratings, we developed a final conceptual model. We wrote items. We tested out those items. Sometimes we literally gave the items to large groups of patients. Sometimes we just tested them out through cognitive interviewing with some of the patients that were involved in the quantitative rating process. And then ultimately, this resulted in our initial sort of version 1.0 of the NET survey scales. And this slide just shows the outcomes of our concept elicitation process. I'm not going to go through all of this. Most of you probably can't even read it. Some of the print is so small, but I just wanted to show you that sort of through these interviews, we were able to identify how many times a particular neurobehavioral domain came up. So you can see repetitive behavior came up a lot, motor behavior, executive functioning, anxiety, social communication, daily living skills, quality of life, and also speech language were some of the more common ones. We also saw ADHD, challenging behavior, sleep were also things that were identified here. We collected quantitative ratings on each of these domains, and you can see from the slide, the black line is just the combined average rating across all the experts and informants, and then the blue and orange lines are the ratings for experts and informants. First of all, the correlation between experts and informants was pretty good. It was a correlation of about 0.5. So we felt comfortable that, hey, the experts and the informants are kind of telling us the same thing here. Maybe not exactly, but to some extent, they're giving us a similar picture. And it also gave us a chance through these ratings to get rid of domains that we weren't going to measure. So GI problems, thought disorder, feeding and diet had the lowest ratings. So those were fairly easy to remove at the outset. So this is analogous to the concept elicitation process. This is just showing the domains that were rated as sort of most important, and then the content areas within those domains as well. So again, not the same domains exactly as the concept elicitation process, but a heavy amount of overlap here: anxiety, quality of life, speech, ADHD, daily living, sleep, etc. So at the end of this process, then we settled on sets of scales, but we ended up not including speech language, seizures, memory, and visual perceptual skills, because even though they were oftentimes rated fairly highly or identified by patients, we felt like these domains already have really good objective ways of measuring them. So we didn't want to develop survey scales for them. And this slide really shows you the model, the final model that we came up with. Sometimes they call this a disease model, but for us, it was really just a way to think about which scales we were going to develop and how those scales relate to neurobehavioral impacts. So mood, motor, executive functioning, social communication, repetitive behavior, anxiety, challenging behavior, sleep, and ADHD were the 9 neurobehavioral impact domains. And then, of course, those domains influence daily living skills and quality of life. And so those were the 2 extra domains. We developed 11 total informant report scales. And this is just some preliminary data that we have now on 120-ish patients and controls that have gone through the baseline assessment process. And you can see we have 31 controls, 13 patients with idiopathic developmental disability. Of those, 3 have an autism spectrum disorder diagnosis. We have 38 individuals with some kind of neurodevelopmental genetic syndrome, and then but without autism spectrum disorder, and then 40 with a neurodevelopmental genetic syndrome with autism spectrum disorder. And I think the big takeaway from the top table here is that most of our neurodevelopmental genetic syndrome patients had intellectual disability or a history of global developmental delay. So why is this important? Because this is a high level of cognitive impairment in this sample. And, you know, that was important to us because we wanted these measures to be applicable across the full spectrum of cases. And so having a large number of individuals with mild, moderate, severe, and profound intellectual disability allows us to take a careful look at, you know, are these measures applicable in these patients that oftentimes are not captured very well by existing scales. And then the bottom table is just showing that we had, for each of the 11 scales, we saw really good reliability in terms of internal consistency and model reliability. And even better, believe it or not, test-retest reproducibility. We collected these scales again on average, or I shouldn't say on average, the median follow-up was 39 days later. So we were looking here not at, you know, long-term stability, but we're looking at reproducibility here. And you can see the correlations are extremely high. So even with brief scales, we can get really strong reproducibility. We feel comfortable that we're reliably measuring these constructs. And the other big take-home message here is that parents were able to complete all 11 scales in 21.5 minutes, which to us was a big win. We were able to see, you know, just from the baseline data, some preliminary criterion-related validity here. We see, for example, in the intellectual disability versus the no intellectual disability groups, you get large differences in daily living skills and executive functioning. These are the kind of differences we would expect given the nature of these groups. And then you also see large differences, very large differences in social communication, with the autism spectrum disorder group showing lower levels of social communication skills, but higher levels of restricted repetitive behavior. Of course, that's the pattern that you would expect to see, given that these are core symptom domains for autism spectrum disorder. So, as I said earlier, we didn't just want to develop the scales. That was an important part of the project, but we also wanted to see, hey, while we're gathering this information from parents, can we also get information from the patient themselves? And this is more of an exploratory part of the project, but I think it's a very, to me, it's a very interesting and innovative part of what we're doing. So this represents a progression from work that I started doing around 2014, where we were doing in-person eye tracking with patients with autism spectrum disorder and other developmental disabilities. And, you know, doing it in person, it has its own challenges and issues, but obviously with COVID, it became more and more important that we move away from in-person work. But in this initial work, we were able to do some studies that really helped us to get a feel for, yes, eye tracking can be useful for assessing the kinds of things we would want to assess in people with autism. So one of those things is social attention. And this slide just shows a meta-analysis we published a few years ago, where we looked at 122 eye tracking studies in autism. There were 1,155 total effect sizes. And what did we see? We saw that the patients with autism, the individuals with autism, had less gaze to eyes and faces and social targets, and more gaze to non-social stimuli. And this, it turns out, there are some methodological issues here, but the effect sizes remain in the most rigorous studies that have been done, and they remain when you compare autistic people to people with other developmental delays or disabilities. So this was important because we wanted these to be fairly specific findings, but also to have some validity across transdiagnostically. So these are the stimulus paradigms. One of the things we did that's different than a lot of the eye tracking work in autism is we were really not interested in one particular paradigm or theoretical approach. We were actually interested in saying, we think there's a broad spectrum here, and we're probably going to see different kinds of social attention discrepancies between autism and non-autism cases across a wide range of paradigms. Some people might show a difference in a biological motion paradigm or in a face versus abstract paradigm. Other folks might show a difference in joint attention. And we also were different than a lot of the prior eye tracking work in that we thought, looking at these stimuli as a whole is probably not the best way to go about it. It may be that autistic people are looking in different places at particular times. And so we were looking at not only specific spatial areas of interest, but also time periods when we thought there was the most relevant social information being conveyed. And what we were able to do is develop gaze-based measures that had the ability to differentiate autism from non-autism cases, as well as show fairly strong correlations with autism symptom severity. And the measures themselves were reliable. The autism index we created based upon diagnosis had an internal consistency reliability of 0.92. The symptom index, which was playing off of ADOS scores, had a reliability of 0.93. So we were comfortable that we could create reliable measures. And we were also interested, as I said, in whether or not these might be transdiagnostic. We knew that we would see the biggest discrepancies in autism, but would we also see things in other developmental delays, disabilities? And in fact, we do. And this slide is really just showing that taking all of the different areas of interest, we could identify this general social attention gradient, and that gradient was different in autism, but also to a lesser extent different in other developmental disabilities. But while we're doing eye tracking, what else can we gather? Can we gather information about language? We know language is really important for autism and for people with developmental disability. It also has prognostic value. And could we develop an eye tracking based screener for receptive vocabulary, receptive language that would be useful? So we started creating these stimuli that were really just very simple picture stimuli, but we would voice over on the stimulus, look at the person kicking, look at the fence, for example. And even with a very short paradigm, this is an 81-second total paradigm, we could, with six stimuli and 16 targets, we could identify stimuli that were quote unquote more difficult because they had lower fixation times like gift and ring and jewelry, and stimuli that were less difficult like eating, drinking, and kicking that had longer fixation times. And then averaging across all of those stimuli, those targets, we could identify a receptive language index that was fairly highly correlated with traditional language testing. So in this case, the correlation was 0.51. And the reliability of the measure that we created was pretty good. So we felt comfortable that not only can we measure social attention, we can measure some things that are useful for language. And this slide is just showing you that if we use it as a screener, so we look at standard scores less than 80, we have pretty good receiver operating characteristic curve, area under the curve, to detect individuals with possible language impairment. So you can imagine in a clinic, you could do this, in 90 seconds essentially, and get a sense for whether or not this person should move on for additional language testing. Okay, so we did this in person, and we did it with really sensitive, very expensive eye tracking equipment. And the thought process, slightly before COVID actually was, okay, that's great, but we can't do this for everybody. Not everybody can travel to the Cleveland Clinic where I was doing a lot of this work initially, or whatever clinic we're at. So could we do this with a webcam? And it turns out that there have been some significant advances in using webcam technology for gaze tracking. I'm not going to go through all of it, but essentially, in-person research grade eye trackers are really, really accurate. The webcam trackers are about an order of magnitude less accurate, but assuming you use areas of interest that are at least 15% of the screen size, you can get pretty good data. And this is actually showing you the difference between in-lab and online webcam-based tracking. And you can see, obviously, the online is a little more variable, a little bit less accurate, but not too bad, not too shabby. So we felt like, hey, we can and we should. And while we're doing that, since we're using a webcam, why don't we grab facial expressions as well? Why do we want to grab facial expressions? Well, there's really good programs for getting automated facial expression analysis, and there's a meta-analysis showing that, in fact, people with autism do have differences in facial expressions. So this might be another good thing for us to grab along the way while we're doing eye tracking. And we already talked about social attention and receptive vocabulary and facial expressions. What else could we get while we're at it? Could we get some measures of overall general sort of sustained attention, processing speed, and single word reading? So as part of our NET project, we developed some additional stimuli here. And we have the social attention stimuli that I was showing you before, the receptive language that you saw before, but also these processing speed and single word reading stimuli, where we're asking people for the processing speed, look at all the stars. And then halfway through, we'll say, keep looking at the stars. So those are the verbal directives. And then for single word reading, we would just say, read the word spoon, read the word adult, and collect their gaze to those. And this is baseline data that is hot off the press. I literally finished this a week ago. We were able to score 11 specific measures from the webcam gaze data and facial expression data. And 2 of the 11 are positive and negative emotional intensity from the facial expressions. The other 9 are gaze-based measures. And they vary from things like overall attention or attentional scanning, like are you scanning the full field of the screen, down to like social and face preference or non-social preference, which is related to what I was talking to you about earlier with social attention, to receptive vocabulary, to processing speed, so speed to faces, speed to objects, and then reading accuracy as well. And a couple of things that I want to just highlight here. First of all, even in our intellectual disability group, we can get these measures validly in many, many individuals. And keep in mind that we really only gave people one shot at this. So I think these percentages are actually fairly conservative. But even for things like face preference and social preference, we're getting about 70% of our intellectual disability group and close to 90% of our non-intellectual disability group that can give us valid data on these paradigms. And then for each of the paradigms, we were able to show really good internal consistency, reliability for the measures. So, sorry, let me move back here. So the other thing I did just this past week was sort of say, okay, we can get reliable measures, but do they tell us things that we would expect them to tell us? And so these are just 4 graphs to show you some construct validity. For example, the top left graph is showing for receptive vocabulary targets. So if we take average fixations to those targets and we create an index there, is that correlated with the parent's estimated cognitive ability? And we see a fairly large correlation there. On the top right, you can see the parent is reporting the child's reading level, the participant's reading level. And again, you see a gradient here where longer fixation times are associated with higher levels of reading. On the bottom left, you can see our social preference measure is highly correlated with the parent-reported social communication skills. And on the bottom right, you see that our non-social preference measure is correlated with repetitive sensory motor behavior. And we've seen these before in our prior work, but it was really interesting and nice to see with our webcam work. So why this is so, I think, important and useful, and now I'm talking about both the scales and the webcam, is we can use these in an inexpensive way. We can have people complete it at home. We can do multiple administrations. It's not as intense for the family. They're not traveling to a clinic. They're not having to sit in a waiting room. They're not having to work with a clinician that they may have just met. So it's much lower intensity on the family and the patient, and the demands are fairly easy. especially for the webcam, we don't require any verbal responses or any motor responses. It's literally just gaze and facial expression. So we think this is going to be a real boon to large cohort studies. Also, obviously, rare disease studies where we have that geographic problem of getting people into one location. And we know that, in order to make this really, really useful, we're going to have to build a platform, and you're going to hear me say that over and over again. We're going to have to build a platform that will automatically administer and score these measures. Right now, it's unfortunately not automated, but we think we can do this. And in fact, over the next 4 or 5 months, I'm working a lot on building that platform. We also think this could be really useful for clinical trials. So if you think about a typical clinical trial in autism and developmental disability, you really have 3 data collection points: baseline, midpoint, and endpoint. And if you just take a trial that had 40 patients in it, 20 per group, the group by time interaction is going to have really good power, strong power for a medium effect size, like a Cohen's d of 0.5. If you do the same trial with an online neurobehavioral evaluation tool, but instead of doing 3 time points, now you do bi-monthly, so you do 12 data collection points, you can almost cut that effect size in half, so about 0.32. And if you did 24 time points, you can actually get down to exactly half the original effect size that you can detect. So there's a lot of advantages to this from a research perspective.
Same number of people.
Same number of people, but with adding all these time points, you can cut the detectable effect size in half.
That's remarkable.
Yeah.
Milton would be.
Milton would be very happy. Yeah. And then the other thing is, even, forget about power. I think you get granularity here, right? You get trajectory, you get the ability to look at mediational effects during the course of a treatment trial, which you can't do when you only have 3 time points, or it's very difficult to do. So ultimately, we have to do a better job on all of these measurements, but I'll end off just in the last couple minutes here, just describing 2 measures that we built off of this process. So the social communication, interaction, and restricted repetitive behavior scales that we developed for the NET, we said to ourselves, hey, maybe a little bit more work here, and we can get to a free open source autism symptom measure that would have really good measurement properties, but wouldn't cost people a lot of money to use, and would be linked to DSM-5, would cover a much more modern understanding of the autism symptom dimensions that we have been able to identify and replicate in large data sets over the last few years. And so we would be able to develop a much better mousetrap in this case for autism spectrum disorder measurement. And so what we did was we developed a measure called the ASDQ, or Autism Symptom Dimension Questionnaire for short. And I'm not going to go into a lot of detail about this. I just want to give you a little bit of an overview. But essentially, with 39 items, we were able to develop a measure that had a very clear factor structure that we were able to replicate. It had 9 specific factors, including 1 general autism spectrum disorder bifactor. And all of the factors had good internal consistency, reliability, and good model reliability. And when we did IRT, we were able to show that we could create measures here that weren't just measuring in the clinical range, that actually we have good measurement precision all the way down to -1 theta, which is, really low average scores. And for the total score, we can get good measures all the way down to -3 theta. So you can think of this very much in the way that you think of a social responsiveness scale, that it's a trait measure in the population rather than in just a clinical range. And then the other thing about the measure that we were really excited about is we can see really good separation between the autism, the developmental disability, and the control groups. And so the measure is really doing what we wanted it to do. The other thing we did was we took the challenging behavior measure we created as part of the neurobehavioral evaluation tool, and we said, hey, maybe we can polish this up a little bit too. So the NET version had 17 items. We added an item to try to better measure property destruction. And we, again, free open source. We did 2 studies, a development and validation study, just like with the ASDQ I just told you about. And we were able to see a very clear 5-factor structure with a general challenging behavior by factor. And again, good reliability, good measurement properties overall. I'm not going to show you some of the construct validity work we've done, but essentially we have really good convergent and discriminant validity for the measure. And then, what I'm going to end on here is when you develop a good measure, you get much more information about things that you might care about. And in this case, one of the things that I care about a lot, my son has challenging behavior with autism. Autism Speaks cares a lot about, because, as an organization, they're trying to better understand how they can impact challenging behavior in their population. When you develop a good measure, you can figure stuff out that maybe was not as obvious or apparent before. So in this case, what I'm going to highlight for you is just that because we have these different measures of different types of challenging behavior, property destruction, aggression, elopement, conduct, self-injury, inappropriate sexual behavior, because we have these different measures, we can look at the rates of challenging behavior in autism and in developmental disability without autism. And in this case, these rates are really based on the 95th percentile of a neurotypical score distribution. So we're counting it as a positive in terms of property destruction or aggression or elopement if the person's score passes the 95th percentile of the neurotypical score distribution. And what you can see here is really, really high rates of any challenging behavior. So when I define any challenging behavior, I mean any of these subscales gets a positive hit. So you're seeing more than 60% in the autism group, whereas it's closer to 40%, and I shouldn't say only, but closer to 40% in the developmental disability group. And when you look at 2 or more types of challenging behavior, you're getting close to 40% in the autism group, as opposed to about 21% in the developmental disability group. And I'm not showing it here on the slide, but the rates are even higher when you stratify the autism group on profound autism, which is a new definition that was put out there recently in a Nature paper. And when you look at cognitive impairment, so IQ scores less than 70, and when you look at severe autism symptoms, you actually see even higher rates of challenging behavior in those subpopulations. So, I appreciate your attention. I know I went pretty fast over some of this stuff. Love to talk to you more about it. But thank you for your attention and appreciate the invitation.
So we have some questions in the chat and from ahead of time. We have a plan about how to cheat and give Dr. Frazier a chance to answer at more length and put more information at your fingertips. I said at the outset that we've known each other since 1998. That was when he was a new graduate student and I was a new professor. And he took my assessment class the very first time I taught it. And then he took a course in measurement with Milton Strauss, which was the most feared course at Case Western Reserve for the psychology students. And he did great in both classes and then developed this as a research interest. So as I'm listening to him, I'm like, you turned out good. You took the ideas that Milton, I gave Milton Strauss a shout out as a sidebar. You took the things that you learned in school and you actually use them, and then you're doing new things now. The qualitative analysis, doing the concept elicitation, ask families and people with lived experience, what do you notice? What is important to you? And then bringing it back and marrying the let's really understand the lived experience, marry that with super fancy statistics, and then the eye tracking stuff I had seen before, but the gaze and how far you're getting with those are game changers. This was an incredible talk, incredible amount of content. We have Dr. Frazier with us for another several hours to get the full HGAPS treatment. So where all the things that he's like, hey, this is free, this is open access, we're going to break the ground to connect that to all of our evidence-based assessment Wikiversity. With Tom's permission, we'll go ahead and add these measures to the assessment center so that families and clinicians would have a way that they could find them, use them. So we're going to break ground on that tonight. So you want to follow us on Facebook and Twitter or Instagram or the YouTube channel, or stay tuned for more updates. So most of you, the way that you heard about this was email, because I'm old, and use the professional listservs. So this was a fantastic talk. We're going to make the recording available on the YouTube channel, disseminate this every which way that we're getting the hang of. But let me give it back to Tom, with Colin moderating and giving us a couple questions.
What was the most surprising thing when you looked at the data? On some of the papers, I've seen the peer reviewers and the skepticism that they had initially, but like for you as the person that tried this, like, hey, what were the biggest surprises?
Do you mean in terms of the measures that we created in terms of like, or are you talking specifically about the webcam stuff?
The listening to you and knowing about your son, the concept of elicitation I don't think that surprised you the same way. You're like, yeah, no, you're right. But with the webcam stuff in particular, you're like, this is hot off the press, ran the analyses last week.
Yeah. Well, I mean, first of all, it was sort of like, phew, reliability. Like, I mean, because you always worry, right? Whenever you create a measure, like, is this going to be reliable? And, I think with webcam stuff, because, these are dynamic measurements, and with the webcam, you either kind of look at the area or you don't. So you get a lot of zeros, right? So it's not a normal distribution for any given area of interest, right? So it's really about piling up areas of interest that are measuring the same construct, right? And so that was kind of my relief at seeing, these high internal consistency reliabilities. It was kind of like, thank goodness, and I kind of knew that already from the work that I had done, but anytime you do it new, that's a big relief. I think in terms of the reviewer stuff, anytime in my experience, I'm sure you have a similar experience, but anytime you create something new, there's skepticism, usually depending upon the reviewer's particular interest, right? So if they're a heavy psychometric reviewer, they're going to want to see lots of reliability and construct validity stuff, right? If they're more of a conceptual or theoretical person, they're going to want to see, how did you come to the content? What's the item content look like, And I think the biggest learning experience for me through all of this was doing all of the legwork, which was a big pain in the butt, and took a lot of time, I think is very likely to make it a lot easier on the publication end to say, no, we did every little possible thing that you would want us to do in order to get to this scale. And not only does the scale work in the traditional way we think of scales working, but we got to it in the way that you would want, sort of the gold standard PROMIS kind of, way that you would want to do it. Does that?
Yeah, no, so speaking as someone who still teaches assessment, this is the state of the art. And HGAPS has a team which is working on gathering translations of measures, and within the world of translations, so like you should actually like talk with people that have the issue that you're trying to measure, have the lived experience, and ask them, does this get it right? And so I'm seeing this coming up everywhere.
So can I jump in?
Yeah,
Sorry.
please.
Like,
It's your talk.
I totally agree with that, but I also don't. Like, I mean, I get the need to ask people, but I also think that the concept elicitation process that we went through was useful from a confirmatory perspective, but I just don't think we got that much new from the lived experience side. If you've seen hundreds of patients as a clinician, then you actually, in a weird way, I mean, I'm a parent, right? But in a way, you have a much better view of the landscape, right? And I mean, not even in a way, like you definitely have a better view of the landscape. You may, as a parent, know a lot of other families, but even then, you're going to be restricted to knowing families that have kids similar to your child. So like, I know a lot of families that have other kids with autism and intellectual disability. And I work clinically with a lot of people with autism spectrum disorder that are very cognitively able, very bright, very, very talented. But I don't have a lot of exposure to those people as a parent, right? So I'm not saying it was a bad thing to do. That would be dumb of me to say. I just did it, but I think I think it's oversold a little bit, I guess is the simplest way to say it. Like, I think you really have to be very careful. If you're going to do it, you might as well do it as best as you possibly can. What is that? Pick very different parents and patients. Try to get, 12, 15, 20 people that are very different and really probe them heavily. So like some people that go through the concept elicitation process, they do it in a way that is a little bit less structured. We did it in a way that was a little bit more structured. So our interview really took that a priori neurobehavioral model and like really broke it down into a lot of potential follow-up questions. Now, it was a semi-structured interview. It wasn't structured, but we really tried to hit a lot there, because as a parent, what's happening this week with my son could be totally different than what's happening 6 months from now with my son. And if you interview me today, you're going to get all the stuff that's important right now, but you're going to get none of the stuff that's important 6 months prior or 6 months from now, right? So I think being more structured allows you to at least we had a lot of parents, if you go back through the interviews, say stuff like, that's not a big deal now, but it used to be a huge deal. And so that counts, right? That in the process, right? Whereas if you do it unstructured, you only get more of the current stuff, I think.
Yeah, which is a huge issue to us, obviously, with mood disorder.
Oh, yeah.
Where it can change week to week. So she's not in the room, but the person that I know is in the Zoom and we'll have a ton to talk with you about later is the other Dr. Youngstrom. So
I didn't know Jen's in there.
So
Hey, Jen.
Dr. Jen runs the training clinic here at Carolina, and she's had to go through the whole what do we do with COVID? What's our protocol for doing therapy? What are the things that we could do for assessment? So as I listen to your talk, the two hats that I'm most likely to wear are the researcher hat. I'm like, dang, this is good. Or the clinician hat. But anyone who puts on the clinician hat is like, wait, so there are these new scales and they're free. How do I get them? Hey, there are these new scales that are free, and I could have them fill them out ahead of time and figure out what should I be focusing on when I actually get to meet with them. Is like, hey, how do I get that? And that's what HGAPS is going to try to help with. But the whole, hey, you could do this from your home. All you need is a webcam, and we've designed this to be easy, not frustrating, not cost you anything, and then to be like, and we'll be able to watch where you're looking. We'll be able to watch how long you're looking at it, and we can do some emotion expression coding, and all of those things are no more time for the family. The thing that I want to highlight that Jen's like, really 90 seconds. You said a 90
So the
second
receptive language paradigm we did originally, we expanded it out to 4 minutes for the NET project, but keep in mind that we really only use 2 minutes for most patients. The extra minutes are for the patients that have really high.
How long was the workup at the Autism Center at the Cleveland Clinic?
3 visits, an hour and a half to 2 hours a visit.
And that was uncheap, but we won't get into that.
Yeah.
Leaving aside the paying for the parking and so, and earlier today, Dr. Frazier was at Teach visiting Dr. Klinger and talking with the team at Teach and the graduate students. He met some awesome graduate students who have been driving all over the state, including, hi, I just came from Guilford this morning. Hi, I just got back from Greensboro this morning. And so I'm listening to this and like, they're hopping in the car and that's like game changing because they're going to the family, they're going to these other clinics. So it's not everybody has to come to Carolina, but I imagine they might have a mix of emotions about, wait, 2 minutes webcam, we could get a whole bunch of this without hopping in the car. I think that they would settle on, that's awesome. So
Well, there's a bottleneck problem too, right? So the measures we've created aren't gonna get anybody to a diagnosis, right? But they could reduce the amount of people that have to go through ADOSs or standardized language testing that don't need it.
well, the other place that would be a game changer too is getting this into the hands of pediatricians. And like, hey, while the family is in the waiting room, they could do this, and you could figure out, do I want to do a scratch and sniff on that? Do I want to refer? There are many ways that I think this is transformational.
Yes, so public domain, and I'm assuming by public domain, they mean free open source.
Free open access.
Yeah, so there's something called the Autism Spectrum Quotient, or AQ. The AQ is free, it's public domain. The only problem with, and there's adult versions, by the way, too. The only problem with the AQ is it's not intended for use in individuals that have cognitive impairment. So that actually slices off probably 30 to 35% of the spectrum from its use. And also, you can't use it in settings where you don't know ahead of time. The SRS is not free and not open source, but has an adult version, the social responsibility scale. And then there's some really not very well validated measures that would sort of maybe fall into those categories, but I don't even think they're worth mentioning, honestly, just because they're not very well, they don't have good norms, they're not validated. Yeah, in autism? Yeah, I published a paper on this using the Simon Simplex collection, and then Will Mandy in the UK has done a lot of really good work on this, and so has Mirko Ojerovic at University of Melbourne. So my work's a little dated now, actually, but the basic findings are that we're probably missing a fair number of very cognitively bright females with an autism spectrum disorder presentation. And the reason why we're missing them, it seems to be that there's probably two reasons. One is they may be much better at something called social camouflaging, which is debatable. There's not great literature yet, but the idea behind it is that either via relationship with mom or with peers or all of the above, or some kind of modifier effects. Like, for example, there's a great paper by one of Dan Geschwin's proteges showing that there are gene expression differences between males and females in the population, forget about autism, but that those gene expression differences actually shift males closer to the threshold for autism, just all of us males, unfortunately, or fortunately, whatever way you want to look at it. So we get this sort of more autistic-like brain, male. But what happens is so the females require more changes etiologically to cross threshold than the males do. And how that plays out in the behavioral or symptom phenotype area is that camouflaging idea. So it could be modifiers, like biological modifiers, or it could be, just behavioral, social, developmental modifiers. We don't know. And then the other big one is females have less restriction of interests. And that's a very well replicated finding. I think I was the first person to publish it, but I think now we got like 4, 5, 6 different data sets that have found that. So females have more age appropriate and less sort of inflexible or restricted interest patterns. So you can imagine why that causes a problem, right? Because of the RRB criteria, of the 4 restricted repetitive behavior criteria, restricted interest is the most important for the cognitively high able presentations, right? That's the one that you clinically hang your hat on. So if you don't have that, then the only other one that you're going to really look at, the only other things you'll look at are sensory sensitivity and a little bit of need for sameness. But again, if you're catching somebody at age 8 or 10 or 12, need for sameness oftentimes improves with age. So you might not get it as much in the females.
So we want to respect your time and end on time. So one more time, I want to thank Colin Park, our moderator, and also the person that wrote the grant with Kira Clemis that got the support from student government to actually bring Dr. Frazier here to do this talk, share it with you, share it with HGAPS. And we're not done with Tom yet. We're like, okay, now we're going to break the ground, figure out how to share more of these materials using the things that HGAPS has already built. We have 2 more talks to complete the spring speaker series. Thank you to SGA, thank you to HGAPS, thank you to NCPA for working with us on the continuing education. I hope your schedules let you come to as many of these as possible. The CE has to be synchronous. We didn't have the time and the money to do the home study. So if you want CE, you must be in the Zoom. But everything else, we're going to do our best to record and get onto the YouTube channel. So thank you a ton for coming.